वेलकम यू ऑल इन टुडे सेशन। और माय डियर फ्रेंड्स, आज के सेशन में हम लोग अपनी जर्नी कंटिन्यू करने जा रहे हैं विद द नेक्स्ट टॉपिक फ्लूइड डायनेमिक्स। इट्स अ हाईली इंटरेस्टिंग टॉपिक। बहुत अच्छे क्वेश्चंस बनते हैं एंड यू कैन इजीली क्रैक इट इफ योर कॉन्सेप्ट्स आर क्लियर। सो बच्चों, स्टार्ट लेते हैं विद द फर्स्ट प्रॉब्लम एंड द फर्स्ट प्रॉब्लम इज रिलेटेड टू द एप्लीकेशन ऑफ एनर्जी इक्वेशन। सी, टेक अ लुक। So my dear, as you are looking in the figure, a lot of things given here. Okay, that this is the tank. Here we have a what pipeline. Then after that we have a nozzle. This is A. This is B. This is C. This is D. So as you are looking, this is at the same level. This is at the same level. Okay. Now take a look. A pipe of 20 centimeter in diameter is connected to a water tank as shown in the figure. Okay, this is the pipeline and the diameter of this pipeline is 20 centimeter. That means 0.2 meter, and this is connected to this tank. Okay, water tank. Okay, a nozzle fitted at the end of the pipe discharges into the atmosphere. That means here we have a nozzle fitted at the end of the pipeline, discharge into the atmosphere. ठीक है. Calculate the flow rate. That means our interest here is, हमारा यहाँ पर जो interest है to calculate the value of discharge. Okay. And the pressure at A, B, C and D neglect losses. They have given in the problem neglect losses. My dear, इस problem को solve करते हुए हम loss consider नहीं करेंगे और they asked to find out the value of pressure at A, B, C and D. Where is A, B and C and D? This is A, this is B, this is C, this is D. Okay. A level from the free surface down 5.75 meter. This difference they have given 1.8 meter. Okay. B level same as the level of free surface. C is above 1.5 meter from B level, or you can say free surface level. Okay, D is at the same level, this same level. Okay, same level, that means this level, The diameter of the nozzle throat is 5 centimeter. That means here the diameter is given, that is 5 centimeter. ओके, टेक एटमॉस्फेरिक प्रेशर 101 किलो पास्कल। तो इस क्वेश्चन में अगर देखा जाए तो हमें प्रेशर निकालने हैं डिफरेंट पोजीशंस पे ए बी सी एंड डी। एटमॉस्फेरिक प्रेशर दे हैव गिवन। नेक्स्ट थिंग वी आर इंटरेस्टेड टू फाइंड द वैल्यू ऑफ डिस्चार्ज फ्लो रेट। दैट मींस डिस्चार्ज वी आर इंटरेस्टेड। ठीक है, फॉर दिस आई एम गोइंग टू अप्लाई द एनर्जी इक्वेशन फ्रॉम दिस टू दिस। सबसे पहले मैं यहाँ पर क्या करने जा रहा हूँ, एनर्जी इक्वेशन अप्लाई करूंगा फ्रॉम दिस टू दिस एंड वी कैन फाइंड आउट द वैल्यू ऑफ वेलोसिटी हियर। Diameter is given, easily we can say about the discharge. देखिए क्या, so this is the case here, my dear. So in this case, if you are looking, so this is one I am considering and this is two I am considering. Or velocity here I am considering V. Okay. Now the next thing here, apply energy equation. Apply energy equation between 1 and 2. So my dear, here the energy will be P1 by rho g plus V1 square by 2g plus Z1. Add to P2 by rho g plus V2 square by 2g plus Z2. No losses there, so whatever be the energy here, whatever be the energy there, that is what same. Since they have given, so this is P1 by rho g plus V1 square by 2g plus Z1, P2 by rho g plus V2 square by 2g plus Z2. My dear, pressure here is what? Atmospheric, ATM. Pressure here is also what? Atmospheric. So here is also what? Atmospheric. Here the velocity is equals to 0. Okay. Here the velocity is what? V. My dear, so here I am going to say that this is Z1 minus Z2 is equals to what? This is V square by 2G. Z1 minus Z2. If you are looking the difference, that difference is this. So my dear, if you are looking, so this is 5.75 plus 1.8 is equals to V square by 2G. So from this we have a value of V. Calculate करिए इसकी V की value को 5.75 plus 1.8 my dear, multiplied by 2 multiplied by 9.81, and this is the square root of this. This is 12.171. So this is 12.171 meter per second. Now my dear, velocity आ गई है. On the basis of the velocity here, we can easily say about the discharge. Velocity multiplied by area, that is going to give you the value of discharge here. So this is now here discharge. My dear, discharge value. That is Q is equals to what? Area pi by 4. Diameter of 5 centimeter. This is 0.05 square multiplied by velocity. Here velocity is what? 12.171. ठीक है my dear. And this is 0.05 square, 12.171. So my dear, it is coming as this is 0.02389, round off is 9 meter cube per second. So this is your answer here. One of the answer is this. Okay. Again my dear, if we are interested to find out the value of pressures here, A, B, C, D. For that we have a need of the velocity in the what pipeline here. And that I am considering that the velocity in the pipeline is what? Vp. So my dear, whatever be the discharge here, the discharge in the pipeline is also what? Same. अगर आप देखेंगे तो जो यहाँ से फ्लो आ रहा है वही तो यहाँ से जा रहा है. सो जो मास फ्लो रेट यहाँ पर है वही मास फ्लो रेट यहाँ पर है. So easily we can find out the value of the velocity in the what pipeline, velocity of flow of water in pipeline. That is I am going to say Vp. So velocity of flow of water in pipeline, consider it Vp. So this is Vp, velocity of water in pipeline. Okay, so easily you can say that this is the what area here, pi by 4, and this is 20 centimeter, no? 20 centimeter. Take a look, 20 centimeter. So this is 20 centimeter square multiplied by Vp is equals to pi by 4. This is 5 centimeter square multiplied by velocity here. Velocity here is what? 12.171. Okay, my dear. Now the next thing here, that this and this is cancelled here. तो ये Vp की वैल्यू आ जाएगी. This is Vp is equals to what? This is 5 divided by 20. That means 1 by 4. And square of that 1 by 16. So this means 12.171 divided by 16. So it is coming as 0.7606. Okay. So it is coming as 0.761 I am considering meter per second. It's a needed for us, my dear. It's a needed for us. Then we can apply the energy equation to find out the value of pressures at A, B, C and D. So one by one we are going to start here. So for first of all A, apply my dear, apply energy equation between किसमें अप्लाई कर रहे हैं? 1 and A. 1 and A. So my dear, what will happen here? So this is P1 by rho g, बहुत ध्यान से देखिएगा, plus V1 square by 2g plus Z1 is equals to PA by rho g plus VA square by 2g plus ZA. Loss is not there. No loss. Now the next, this value P1 is equals to atmospheric pressure. Atmospheric pressure they have given. Atmospheric pressure they have given 101 kilopascal they have given. So my dear, I am going to put here. So this is 101 and this is kilopascal, 10 to power 3. And this divide by 10 to power 3 multiplied by 9.81. V1 value is equals to what? 0. Velocity यहाँ पर तो 0 होगी. Z1, ZA here I am going to take. So plus you can say Z1 minus ZA is equals to. अच्छा, VA पे velocity at A is same as the velocity in the watt pipeline. So my dear, if you are looking here, so this is PA by rho G, 10 to power 3 multiplied by 9.81 plus VA square, that means this is 0.761 square divided by 2G plus, my dear, this is ZA. ZA we have taken here, so that means no need of this. So this value Z1 minus ZA, this is 5.75. Okay. My dear, so this we have need here. So this is, my dear, this is your 101 into 10 to power 3, 10 to power 3, 9.81 plus this value is equals to 5.75 is equals to PA 10 to power 3, 9.81 plus this is 0.761 this is 0.761 square divided by 2G. Okay. So when you will solve it, then you will get the value of PA. I have done my calculation work. I am going to write the value of PA here. So this is, okay. So this is, my dear, I am getting 157.12. So from this I am getting the value here. PA is equals to 157.12 kilopascal. And this thing I am going to make it in the block. So this is again our answer here. Now I am interested to find out the value of pressure at B, C and D. देखिए क्या B, C and D. For this I am going to apply the energy equation between 1 and B. Now see. So this is apply energy equation between, my dear, this is 1, this is 2. Okay. So 1 and B पे apply कर रहे हैं, 1 and B. Now see, so this is P1 by rho G plus V1 square by 2G plus Z1 is equals to PB by rho G plus VB square by 2G plus ZB. अच्छा, Z1 or ZB, that is what same. So this and this is cancelled here. अच्छा, this is 0 and this value they have given. This value कितनी लेंगे? VB is same as velocity of flow of water in the pipeline, that is 0.761. I think what we have done here, the calculation 0.761. ठीक है, वही value. So my dear, here if you are going to write, so this is 101 into 10 to power 3 divided by 10 to power 3, 9.81, and this is equals to PB by rho g 10 to power 3 multiplied by 9.81 plus, my dear, this is 0.761 square divided by 2 g 9.81. So I have done my calculation work and it is coming as, from my side, my dear, this is, so it is coming as PB is equals to 100.71 kilopascal. Again, my dear, this is the next answer. Okay. Now the next discussion here, that to find out the pressure value at C and D. So for this, apply energy equation between 1 and C. Apply energy equation between 1 and C. Okay, my dear. See what happens here. So this is P1 by rho g plus V1 square by 2g plus Z1 is equals to PC by rho g plus VC square by 2g plus ZC. Now this is P1, they have given 101 into 10 to power 3 divided by this is 10 to power 3 multiplied by 9.81. My dear, already understood that this is ATM. This value is equals to 0. So plus 0. Z1, ZC. So my dear, ZC level is more. So this is here is equals to PC, we are interested to find out, divide by 10 to power 3 multiplied by 9.81. Okay, plus VC square. VC is same as the velocity of flow in the pipeline. This is 0.761 square divided by 2g. And my dear, for your kind information, this is ZC minus Z1. ZC minus Z1. And ZC minus Z1 difference is equals to what? 1.5. Okay. So this is 101 into 10 to power 3 divide by 10 to power 3 9.81 is equals to PC by 10 to power 3 9.81 plus, my dear, this is 0.761 square divided by 2g plus this value is equals to 1.5. Solve it, you will get the value of PC is equals to whatever I have the calculation. This is, my dear, 86 kilopascal. So this is again the answer. Now the next discussion here. The last thing to find out the value of pressure at D here. So this is apply energy equation between 1 and D. 1 and D. So my dear, this is P1 by rho g plus V1 square by 2g plus Z1 is equals to PD by rho g plus VD square by 2g plus ZD. Okay. Now as usual, this is PATM. This value is equals to 0. So this is 101 into 10 to the power 3 divided by 10 to the power 3 multiplied by 9.81 plus Z1 ZD. ZD, my dear, this or Z1 is this. Z1 is this. That means difference here is 5.75 plus 1.8. So that means you can say Z1 minus ZD. I'm just going to write it. Z1 minus ZD difference is 5.75 plus 5.75 plus 1.8. And this is equals to PD by rho G 10 to power 3 multiplied by 9.81. Plus, my dear, kinetic head at D. Pipeline is this. उसके बाद नोजल लगी है, तो यहाँ पर क्या हो जाएगा? This is 0.761 squared divided by 2G. So you will get the value of PD. PD is equals to, my dear, I have done my calculation work. So this is coming as 73 point. This is 174.776. So this is 174.776 kilopascal. This is again the answer. In this way, इस क्वेश्चन में आपने सीखा है कि एनर्जी इक्वेशन कैसे अप्लाई करना है. How to apply the energy equation. Now this is your time, my dear. I am side here. Please note down this one. Do it fast. Take a look. My dear, first of all, pause your video. Note down the problem. Again, going to shift the slide. My dear, pause your video. Note down the problem. Solution. Again, pause your video and note down this one. Please. Yes, my dear, completed. So now we are going to involve in the next problem. But my dear, before going to involve in the next problem, one more discussion, very special discussion in this problem. देखिए क्या है, जब यहाँ पर आपने प्रेशर वैल्यूज कैलकुलेट करी हैं, चाहे वो ए पे कैलकुलेट करिए, बी पे कैलकुलेट करिए, सी पे कैलकुलेट करिए, डी पे कैलकुलेट करिए, तो आपने एनर्जी इक्वेशन लगाई है, तो आपने 1 पे प्रेशर वैल्यू ली है. क्या लिए 1 पे प्रेशर वैल्यू? पी एटमॉस्फेरिक वैल्यू इज देयर. दे हैव गिवन द वैल्यू 101 किलो पास्कल दी थी. तो जब आपने यहां पर एटमॉस्फेरिक प्रेशर वैल्यू ली है, तो आपने ए पे, बी पे, सी पे, डी पे जो प्रेशर कैलकुलेट किए हैं, दैट इज इन एब्सोल्यूट में कैलकुलेट किए. माय डियर, अगर आप यहां पर गेज वैल्यू रखते तो गेज वैल्यू हियर इज इक्वल टू व्हाट? 0. तो फिर जो प्रेशर्स आपके आ रहे होते, दैट इज इन द व्हाट? गेज. लेकिन since they have given the atmospheric pressure value, we have taken here. So all the pressures, whatever we have calculated at A, B, C and D, that pressure values are in absolute. So this is a very, very special point here.